stuff has arrived. Some zip ties, some assorted nuts and bolts. What have we got? We've got 6mm coarse thread, and that will be to fit my little camera mounting bracket here. I have some 8mm coarse thread, some brass washers. We have some thin 6mm dowel, and we have a 6mm axle kit. I'm not sure if you can guess what I'm going to make with this lot, but it'll be interesting. Okay, so what are we doing today? Well, we've got a collection of nuts and bolts and bits and pieces, an axle kit, some dowel, and a little GoPro mount. I wonder if I'll give you a few seconds to have a think about this and see what you think I might be making. Well, if you haven't already guessed, I'm going to try and make a camera stabilizer of sorts. I have a bunch of these little leftover shielded bearings from 3D printer building, so I'm going to try and utilize a few of these as well and see what I can come up with. Hopefully it makes for better viewing pleasure. This is not going to be my typical video because I'm very tired, my energy's lacking, so I'm just going to pretty much do a quick little update throughout the throughout the project, and you can see the state of my mind at the moment, and we'll see where we go from there. And that little ping ping you might have heard in this background, that's my new YouTube manager. You'll probably notice some changes on my channel, and that's his work. Just let him in to see what he does. I'm not in it for views and fame, but he's been bugging me for ages to let him in and have a go, so why not? See what he can do. As long as he doesn't delete the videos, I think we'll be fine. Anyway, on with the project. Right, so about 6 hours has passed and all sorts of distractions have happened and whatnot, but I've soldiered on and I've come up with a whole bunch of different pieces. I'm now over into Repetia Host, and we're in the I've been through the slicer. The printer's just about to start. I've just heard it. Let's see if it's going to do its thing. Oh, my finger was in the way. Looks like my calibration stayed pretty well correct on the printer. So yeah, we're going to leave this go and see what happens. I'm not going to bother time-lapsing this at the moment. I'm sorry guys. It's a 6-hour print and it's already nearly midnight, so I'm just going to let this do its thing and we'll see what happens in the morning. Hopefully my computer doesn't crash overnight because I didn't put this on the SD card. Right, slight update, it got through the first layer. That usually is a good sign when all the brims don't peel up. I'm doing PLA and about a 40-degree bed and about 200 degrees, about 210 degrees Celsius for PLA. And it's also Australian made stuff, which originally was pretty useless, I have to say. I had a lot of trouble with it, but I was doing mostly ABS. They've apparently done a lot of work in their production line, and this stuff's now quite good. So we're going to let it just go, and hopefully we'll have a working gimbal by morning. Hopefully. Right, so one last go, or one last update before I call it a night and go to sleep. So far, no nozzle blockages, no tangles, no nothing. I think we're going to be right for the rest of the night. Usually if I can get it this many layers in, we're going to work. So yep, we're going to call it a night, and we'll see what it's like in the morning. Alright, so overnight this all printed very nicely and it's all going to come off the bed easy. Glory of hairspray. So let's go and get this assembled. It's the noisy time of morning, so yeah, we'll assemble it all and see what we can get out of it. Alright, so I've got the parts off the printer and I've given them all a quick, just gentle clean up. We'll do it properly in a minute. And I've done a quick test assemble, which of course is now falling apart in my hands. Let's swing you around so you can see what I'm doing here. So the general idea, and there's some bits here yet to be made, is that you've got rotational here, you've got x-axis and you've got y-axis. I haven't put this flange on yet to hold the nuts in, so it's all very loosely sitting here, but the idea is you should be able to move it around. This is not the best or the most stabilized camera, but it's designed to be the simplest one that I can come up with. And there's plenty of these out here, so if you want something better you can choose somebody else's. This is an axle off a kid's toy car axle replacement kit. So yeah, that's I'll be including the part number for that. This is the mounting for the camera mount, and I dropped the screw just before. Take a 6mm screw through here, coarse thread. That will be the camera mount. So that'll go on there, and I will be casting a white metal weight to go under here, but you could use practically anything. That's just to give it some offset for the camera. And at some point I'll work out some damping, maybe a spring or something to go in here, just to help dampen things, the rocking of backwards and forwards a little bit. So yeah, we're getting there. I do have to reprint this piece here. I need to make a change. The lip on there means that that bearing can pop out the top, although it's really not the end of the world because most of the weight is downward force, but I still want to just redo that lip on there a little bit. It's just not quite thick enough. This is held in by a split pin on the shaft here on the cutting mark, and I'm going to need to squish that down when I increase the lip slightly on that. But we're getting there. We've got all our axes working. There'll be 2 nuts in here to hold these apart, and that will self-center once that's the case. And once this flange is in here, I'll be able to hold this without it trying to come out, and I'll make some sort of adapter for a stick or handle or whatever you want from there. I might make a handle that I won't print, just because this is going to go on Thingiverse, but I need to give these a bit of a sand up and clean them up a little bit too. But anyway, I'll make the upper clamp for the main bearing retainer here, and yeah, we'll assemble a few other things. Now these are designed for using the 3mm screws or nuts and bolts, so you can drop little threaded inserts in there, which I have some somewhere in amongst my box of springs and stuff. I should have some threaded inserts here, so I can do this one-handed. These are notoriously hard to grab by hand, so I'll grab one with a pair of these cutters and show you what we're talking about. These are just little 3mm nuts with a knurled edge on them, and if you screw them onto a 3mm screw, you can drop them straight in on the end of the screw when they're hot into plastic. So yeah, it is a viable way of getting a threaded insert in there if you want to do it that way. And you can get smaller 2mm and whatnot. I've made these holes exactly 3mm so that when you put a screw in, it cuts its own thread. So yeah, let's continue on. Alright, so I've given things a brief touch up on the belt sander with a really coarse belt, so they don't look good, but I'm not going for looks at the moment. Now, I've assembled this section as a start. I've put my 3mm screws in, and they're about 10mm. It's not that critical, but yeah, that's about the correct size. Now, this does wobble a little bit. If you want to stop that, you can whack a bit of epoxy in there, but for the purposes of this, that's probably not going to really matter too much. I've stuck a nut on the back here. That's where the handle will go. I've still yet to design that. We'll get there in a minute. I'm currently printing my upper bracket here. I'm reprinting that, and I will be including that STL on the Thingiverse listing. Now, let's go over some fasteners. So I've been to Bunnings and I picked up some M6 by 65mm. They're security bits. They do include the driver bit with them. You don't have to use specifically these as long as it's got the same head diameter and thickness, because these guys will matter. These are for the 8mm. I've used the same brand in 8mm. I've used the M8 by 35mm. Again, you're not stuck to exactly these. This is just showing you what I'm using. The axle shaft is a Bunnings kit. If you can sort of read here, it's a 5/16 adjustable plate axle with caps. Most of that we're not really using, although we do have the end caps here if we need them. And it has some instructions on how to cut the axle and whatnot there. I'm hoping the resolution is high enough to see that, but I'll take a photo and I'll include that with a Thingiverse post. I also have, in case I need them, I've got some flat washers. These are just what was available on the shelf at the time. Now, there is an imperial thread that's used for tripod bases. I don't recall what it was. I think it's something like 5/16, but I'm using a 6mm coarse thread which jams its way in there well enough, but you wouldn't want to put it on too tight. You'd probably never get it off. But that's so you might want to substitute one of these for something specific to a tripod mount. But you could use pretty well anything you want. I set this up for a 6mm nut, so yeah, or a 6mm bolt. You can use whatever you want for that. Now let's get this shaft and show you how that bit works. So this is the axle shaft. There's a scoring mark here where to cut. Now typically in some of these toy cars, this would be the steering axle and this would be for the rear wheels, but we're going to use the whole shaft. And this central bit here, we're going to stick one of the supplied split pins in there, and I folded it over, trimmed it down and given it a bash with a hammer. There's a reason for that. We're going to stick our bearing on here. Now that will hang vertically like this, and yes, it can bounce up and down a bit, but that does mean you can remove it if you want. If you were really determined, you could either put a bit of something on there to stop it sliding down, or you could drill another hole and put a second split pin there. Really, it's up to you how you do that. Now, I believe I sanded one of these and I probably sanded the wrong one. Doesn't matter. When this bit goes over, there needs to be a bit of clearance so that this bit can actually clear the inner radius here, and that will be reduced when the second piece is printed for this. Obviously I sanded the wrong bit here, but we'll get this positioned in the middle and show you how to do that bit too. Right, so we need to assemble the central gimbal here, and for this we need two 8mm, two bearings, and these are 608Z shielded bearings. They're used in 3D printers quite a lot, like the RepRap series. So what we need to start with is put nut on each bolt and whiz this on. So do them all the way up, not tight, but just do them right up to the head. Will make your life a little easier. Right, so then we thread a bearing on each bolt like so. Oh. And then we poke a bearing in here up to the stop. And this makes it a little easier to get them in. Now from here we need to wind the bolt back just a little bit, about 5 or 6mm. If you can see what I'm doing, I hope the camera angle's good there. Right, slide this underneath, and this should be, if I've done it right, the tolerances should be tight enough that it should snap into place there, and then we'll have it loosely in position. Now from here, what one would normally do is would bolt on, or you would screw on the top section here. I'm reprinting another one, and again you would use some 3mm nuts and bolts to go through these to join the two together. I might even use some self tappers or something like that to go through there. I've got some that will do the job nicely. That will make our horizontal axis, or rather our x-axis, and that should spin freely, just barely missing that gap in there. So be careful with the size of the heads you use in there. Once you're in here, you can adjust these nuts and bolts till it's in a central position that you like, and so that your amount of tension is correct. That amount of tension will give you a little bit of a damping feature, so it will tend not to rock backwards and forwards so much. But we might actually add springs later on. I haven't really gone that far in the design. This is kind of designing as I go here. These come forward as far as they do, so that if you bump up against something, it doesn't bump this gimbal, so it helps keep it a little bit more isolated from bumps and knocks. It makes it a little easier to grab hold of if you need to. Now this whole assembly should spin quite freely here. We'll have to get on with designing a pole mount. I'm going to mount it on a pole, but it shouldn't be too hard to come up with some kind of a handle for this. And it looks like it doesn't sit balanced at the moment. It will as soon as we put that shaft in there. So let's assemble the next bit. Okay, so the next step, we're going to take this shaft and we're going to attach the camera mount, which is a pretty basic way of doing it. there isn't any real need to do it any further. Now you can shove this over here, you can insert some glue in there if you want, or you could drill a hole through the shaft. It's entirely up to you. I'm going to use some super glue, and that sits on the top. Can't get much more simple than that, and it's deep enough that there's a bit of purchase. So I think if you were to do that, I would probably sandpaper the shaft and add a bit of glue. That's how I'm planning on doing it, but each to their own. The actual camera mount section is the aforementioned 6mm that we talked about. That's going to get installed on here, and then whatever arrangement of camera mount you want on here. Now I'm planning on mounting a GoPro on here, so this is suitably lightweight, but this will give me the ability to change camera angle and whatnot. It should go in fairly tight, so that will allow me to make a lot of variations, and that will simply sit on the top there. And because I'm going to have the camera angled down slightly, this allows me to have the center of gravity right over the top of that post. But it doesn't matter. The amount of weight you put on here should determine the behavior of this mount. So you can add and subtract weight, and you can move it up and down the shaft, and oh my. And there's a whole bunch of other things you can do to adjust those variables, but we'll see how this goes when it's finished. So I now have about another half hour to wait until the top of this clamp is finished, and then I've got to come up with a handle of some kind. So we'll jump to that bit. Alright, so our camera mount is on very firmly, and used a bit of Loctite. Now I'm pretty sure this is the civilian version of Loctite 406. But it's gone in very, very well, and I roughened everything up. And I put a little bit of a drop in that hole first before I shoved it in there, in the hope that that would create a bit of an anchor point too, which it seems to have been the case. So we're just about there, and then we'll put a test weight on this and try it out with an actual GoPro. Alright, we're down to the last bit. This is the tube adapter bush. I've only let this print halfway because it would be too long if I let it print all the way. Let's grab the actual bracket here and we'll compare it. This will need to fit, and we have a bottle of water here for temporary ballast. This will need to fit over this, like so, with just enough room for a nut. We're going to improvise a captive nut on that so that we can remove this at a later date. So we'll get that done in a second. Now the tube I have is off an old Bunnings pergola, or rather a new one that got destroyed in a previous video. You can find that if you scroll through the last few Argo videos. Anyway, we're going to hammer this in here once we've got a captive nut in, and we're going to heat set the nut into the end here, and we're going to use Mr. Stoner torch here to do that. Alright, we've got our nut set in there, nicely heat set, and the bolts also cut a bit of a thread in the process. So now we just need to hammer that into the tube. Alright, it's all hammered in and in the end of the tube. And there's even a gap here. I could put a retaining screw through, but it's such a tight fit. It's a 23mm inner tube, or inner diameter tube, and a 23mm print, which was a bit large. It's wedged in there really tight. I don't think it's coming out. So let's get this attached to the gimbal. And we're assembled on the end of the pole. So time to put our camera on and take it for a test run. We'll use our bottle of water over here as a ballast weight. We can adjust the amount of water we want. I think I have spotted a problem with this in that the way or the eccentric way that I've mounted the camera will cause it to spin in some circumstances, but pretty sure technique can overcome that or exploit it to our use. So let's do a test run. Well, you guys are going to get a bit of a Steadycam tour of my workshop, and because it's the only place that's well lit enough to do this. I think as I spin around, if I do it slowly, we can pan nicely. If I try and whiz off real quick, the camera's going to spin around because of the off-center position of the weight. I'm hoping that the GoPro's motion detection or motion stabilization is going to be enough to cope with the rest of this. I have another solution how to stop that spinning, and I'll try that in a minute. But we should be able to do nice smooth pans and tilts come up and down like this fairly nicely. We should be able to come around. Hopefully this doesn't make you guys seasick. I'm noticing it's wobbling a bit. So I might need to put a little bit of damping on this. Alright, so yeah, at least up and down is nice. We can come up and down nice and gently. And side to side, if we go slowly, is alright. So if I suddenly decide to change direction in a hurry, we're going to spin around. So let's put some damping on this and see what happens. But at this point, let's try it as selfie mode. So yeah, you should be able to see what's going on pretty well here. We have down here, let's see if we can spin this. I have a little bit of blue tack sitting on my laser cutter here, and I've just dropped it on the floor. We'll put a little bit of that in this central bearing here, just to dampen its movement slightly. And we should be able to swing around like this without worrying about too much rotary motion. Especially if I change direction quickly, you should see that. Now, oh, I bumped into the laser cutter with a counterweight. We should be able to come out to an arm's length, and that should work relatively well. It's better than it could be. So the next thing I'm going to do is work out the counterweight properly, and I'm going to melt down some of this stuff. This is lead-free white metal. I have a little bit of DSL here, which is lead stuff. I might use that for the ballast weight because I can't use it for jewellery and other stuff. And I'll paint it to try and keep the contact with the lead to a minimum. But so far I'm pretty happy with this. I think the next step will be attaching it to the Argo and then coming back out and cleaning my workshop again. So let's go back to the desk. Alright, well, we're pretty well done with this build. I'm not going to go through the counterweight casting and whatnot. That's an entirely optional thing. I'm sure you guys are going to come up with all manner of ways to modify this, and probably better ways of doing stuff as well. But in any case, I'll put down below the link to the Thingiverse Thingiverse listing, and we'll go from there. But anyway, I hope you enjoy it, and I'll see you all in the next one.